Let's take a look at E. This is question 1E from the 2016 end of year algebra exam for year 12 for the NCEA 2 exam. And we've got a question here that asks for a few things actually. It says find positive integer values, so they've got to be positive integers, for K, so the quadratic equation has real rational solutions. Now, in order, so finding positive integer values, well, that's fine. For it having real rational solutions, a rational solution only comes about when the discriminant value is a square number. That's what we're going to have to find, when the discriminant value is in fact a square number. That's meant to be a triangle, by the way. So it's a triangle. So it's discriminant. Yeah, discriminant. It's a terrible triangle. But imagine that was a triangle, meaning discriminant. All right. So this has been laid out very nicely for us already. We have the coefficients of this. So if we're going to use the discriminant function, or we've got A. So I'll write down A. A here is going to be a 2. B here is going to be a 4K. C is going to be all of this thing here, which is 2k squared plus 3k minus 11. So we're going to put that into the discriminant. Now the discriminant, of course, in this case, because it says has real rational solutions. Now, this could be a number of things, actually. It could be one solution that is the same, meaning like 2 or 3 or 5 or -6 or whatever twice, in which case it would be equal to 0. But it also can be greater than 0, meaning it cuts the x-axis in more than one place as opposed to cutting in just one place. So if it was cutting in more than one place, it would be greater than. If it's cutting in just one place twice, it's going to be equal to. So it's going to be greater or equal to 0, I think, is the best way of writing that, given that this is kind of a really wide open question. It could be either or. So in other words, what I'm saying here is the value here, you could be looking at something that, let's say, cuts at one point like there, or you could look at something that cuts like at multiple places here and here. This cuts at that point there twice, so that's equal to, this one here as the discriminant is 0. This one here is the discriminant is going to be greater than 0 for this one here. So either are possible. So let's go plonk that into the discriminant itself. So we've got b squared minus 4ac is greater than 0. B squared, well, that's going to be 4k all squared, minus 4 times a times c, which is the whole of that thing. Now I'll put that in brackets, 2k squared plus 3k minus 11, all greater than 0. Now let's simplify this a bit. So it's 4k squared is going to be 16k squared minus 4 2's are 8. And I'll restate this thing here, 2k squared plus 3k minus 11, again, greater than 0. Let's now expand this out here. So I've got 16k squared, negative 11 times 2 is going to be minus 16k squared, which by the way is really handy because we've got a 16k squared and a negative 16k squared. So immediately that is all going to disappear. Negative 8 times 3k is going to be minus 24k, and we've got negative 8 times negative 11, which is going to be plus 88, all greater than 0. All right, so straight away I can go cross this out, and I'm left with negative 24k plus 88 is greater than 0. So so in terms of critical values, critical value of k here is going to be, and I'll just write, let's see, 24. Well, I'll do it properly. Yeah. So we're going to have negative 24k. I'm going to subtract the 88 from both sides. So it's going to be greater than negative 88. I'm going to divide both sides by negative 24. So I'm going to divide this by negative 24 and divide this by negative 24. And the moment I do that, and we've got leaving k on its own, then this now is going to swap sides, and we've got negative 88 over 24. Now, if I'm to put that in as a fraction, let's have a look. So 88 over 24 and we've got 11 over 3, which is a lot more friendly. So we've got 11 over 3, and it's all positive. So that's the critical value of k. Now, that's, in other words, that's the point. If you had this here, what actually is that? What's 11 over 3? The exact value of that is 3.667, and so on. So in other words, it's over here somewhere, and it's going to be 3.6. I'll put 3.672 dp. There it is. So this here is going to be k along here, and this is going to be the f of k, the function of k, and this is going to be some sort of, it's going to cross at this point somewhere. All right. But that's really not what we're interested in. We're really interested in finding the values for which this is going to be true. So we're looking for now real rational solutions. So I'm going to take this thing here, and I want to find things where this thing here is 24 is true. So let's have a look at that, yeah? So I've got to have negative 24, negative 24k, here it is, plus 88 is greater than 0. So what we're going to do is we're going to try some numbers, and the numbers we're trying for, first of all, they've got to be a positive integer, and secondly, they've got to be a square number in order for this to meet the criteria that this, or criterion, that this here has got an integer value that is a real rational solution when substituted into here, substituted into the equation to make the equation true. So in other words, what are the values of k that satisfy this clause here? So they're going to be positive, and they're going to be square numbers in order for this to have real rational solutions. So let's see if we can find some. So I'll put here, I'll put try 0. So here we've got 0, and when we do that, by the way, try 0, and of course put no solution, as k must be positive. What about trying a 1? Let's try 1. So we're going to have, this is going to be 88 minus 24. Now, 88 minus 24 means that we now have a discriminant, because this thing here, by the way, is the discriminant, yeah? That is the discriminant. So now this is going to equal 64. So this satisfies both solutions. So in other words, this is put valid solution. Yeah, it's a square number and it's a positive integer. Yes. So in other words, 1, put a tick here, is a definitely a solution. Let's go try 2. Let's try 2. See how that plays out. So now I'm going to have 88 minus, or 24 times 2 is going to be 48. Now 24 minus 48 is going to be 40, and put no solution. And it's not a solution because although it is a positive integer, it's not a square number. Square numbers being things like 4, 9, 16, and so on. Yeah, this is not. 64 is though. It's going to. This is 8 squared, but this is not a square number. Okay, let's go try 3. Here we go. I'll put a 0 here. We actually tried 0. Well, no, it was not good. I'll put cross here. Cross here, not good. 3. Let's have a look. So we've got 88 minus. Now, if I got 24 times 3, 24 times 3 is going to be 72. It's 72. And 88 minus 66 is going to be 16. And 16 is a square number. So this is a valid solution. SOL with an N underneath it, yeah? And then we get to 4. Let's try 4. Because you might think we're going on forever here, but I can see why we wouldn't be. If I got 88 minus 4 times negative 24. Well, let's have a look at what that is, and that's interesting. So I've got 88 minus, I'm going to have here 4 times 24. And I got negative 8. I'll just put here 4 times 24 so you can see what I've done. Is equal to negative 8. And these solutions from here on cannot be valid because all of these are going to be negative, yeah? So no solution, and put here negative number. Yeah. So this is valid. Put square number. Square number. Not a square number. And this one is a square number. And of course, it's a positive integer. Okay, so let's see how that flies now. So we've actually found a valid solution in 1 and in 3. And that's what we're on. So we're going to say, therefore, solutions for K that satisfy question statement, or I'll put statement in question, yeah. Satisfy. I'll put positive, real rational. Satisfy positive. Oh, you can't see that. Sorry. Positive, real, rational. Rational. I put rationad. I try and get the A and the D at the same time. Rational. R K. I put is an element of, and it's going to be 1 and 3. 1, 3. And that's the only solution that we have. I've just written it in set build notation, but you would say is that or that, or you could just say, R K is equal to 1 or 3, or you could say K is an element of 1, 3 in set build notation. So that's how I would write the answer. Hopefully that makes sense.